In today's lecture, we are going to learn what is constant folding in code optimization. So what is that exactly? We'll see here. We can say what is constant folding. It is a process of recognizing and evaluating constant expression at compile time rather than the computing them at runtime. So what we are doing, it is a process of recognizing and evaluating constant expression at compile time rather than computing them at the runtime. So that is the meaning of constant folding. So what is that? We will learn with the help of example. Suppose there is a expression giving like this: x is equal to 10 plus 2 into 3, right? Suppose this is expression and we need to solve it. So here we are able to see that all are constant here. So if we give the expression like this, then compiler will calculate all these things in different phases according to the priority of the operator, because it is having higher priority. So first it will solve that, then it will put the output of this, then whatever output is there, then again we will use this output, then again it will go to another phase and it will do all the computation. So it will take time, right? So it will take time. So as we all know, these are all constant and these values are not going to change, right? These values are constant, so these values are not going to change. So instead of putting all these values, what we will do, instead of doing all this computation in the compile time, we will directly calculate all these values. So we know because of this is having higher priority, so it will be 10 plus 6, right? First we will solve this, then after that what will come? 16. So instead of putting the line like this, we will put line like this. So that is the meaning of that. So we can say, instead of putting different values, because these are a constant value, just calculate them and just put this value. So it will reduce our time and reduce our cost also. So we can say that if we do like this, it will reduce time and cost. So that's what we are doing, that recognizing the constant expression, because it's constant at compile time instead of runtime. So better not to give these things like this, better give like this, so that compile time will reduce and cost is also reduced, right? So this is one example. Another example, suppose if a less than b, then go to L1, else go to L2, right? Another example, and if a and b are constants, and having values like a is equal to 10 and b is equal to 20. So instead of putting all these lines, what we can do, then we can write directly. What we can write, if a less than b, then go to L1, because from the values it is clear. We do not need to write another line, because if a less than b, as we are able to see, a value is already fixed, b value is already fixed. If in the case it is constant, if it is not constant, then it will not work. I am talking about if these values are constant. Then instead of putting these three lines, we can put in one line only, if a less than b, because a value is always less than b, because it is fixed, it is constant. So we can write directly, if a less than b, then go to L1. So this is another example, that evaluate constant expression at compile time rather than computing them at the runtime. So we can say that if any variable value known at compile time itself, then so what is the conclusion? We can say, if any variable value known at compile time itself, compile time itself, then evaluate the expression and replace the expression by its value, so that it will reduce the compiler time also in solving all these things in different phases, because we know there are multiple phases by which we can solve an expression, and it will reduce the cost also, because if phases are less, then obviously cost is also less. So this is all about the constant folding. In next lecture, we are going to learn constant propagation with the help of an example. If you like it, subscribe it, share it, and comment below. Thank you.